In today's class, I will start a new topic, that is density. Now, the topic in the book is relative density and its measurement by Archimedes' principle. So, we are calculating the density by using the Archimedes' principle. So, I hope Archimedes' principle is clear to you because that we have already discussed in the previous class. Now, density is actually it means that how dense a particle is there in any matter, that is either solid, liquid or gas. In solid, the density is great, okay? It's very huge because the particles are very tightly packed, so the density of a solid is more than the density of a liquid, and the density of a liquid is more than the density of a gas. So it is how closely or tightly the molecules are packed that defines density. Few examples, for example, in a book, if equal volumes of different substances such as wood, iron, zinc, water, glycerin, mercury, etc. are weighed by physical balance, we find that their masses are different. Now suppose if you take a ball of cotton, a ball of iron, okay, just separately, what you can see is the volume, the area which that is covering. If it is same, even though the mass of the two particles will be different, if you weigh them, the mass will be different. The cotton ball will be way more lighter than the iron ball, because the reason behind this is the density of the particle. The density of the solid or iron is more than the density of the cotton ball. Cotton balls the molecules are very loosely packed, whereas in iron the molecules are very tightly packed. So that is density. Now, formula for density. When you have to calculate the density, then the formula for density is equal to mass divided by volume. This is how we calculate density. Now the mass is a scalar quantity, even volume is a scalar quantity, so density is also a scalar quantity because density doesn't have direction, it has only magnitude, it doesn't have direction. So density is a scalar quantity. Density is denoted by rho. Okay, this we read as rho. RHO rho. This is how we write density. So density is equal to mass by volume. Now the unit of density. We don't have a unit for density itself, but we have to derive a unit for density. Over here, unit of mass is kg. The unit of volume is meter cube. Okay. So unit of mass is kg and volume is meter cube. So unit of density is kg per meter cube. So when we have to write the unit of density, we write kg per meter cube. This is the SI unit for density. While doing calculation, we have to remember that. Now this is in terms of SI unit. But in terms of CGS unit, in terms of CGS unit, or when we have to convert 1 kg per meter cube into gram per centimeter cube, then how do we do that? That is, over here, 1 kg is equals to 1000 gram. Okay? And for this one, 1 meter is equals to 100 centimeter. So it is 100 centimeter cube. Okay? But this is in terms of cube. So if you do the cube of 100, how much do we get? It will be this much. Okay? Centimeter cube. Okay? Now we can cancel out the zeros. 3 zeros and 3 zeros will be cancelled. So ultimately it is 1 by 1000 centimeter cube. Or 1 by 1000 we can write as 10 to the power minus 3 centimeter cube. Sorry, this is gram per centimeter cube. So 1 kg per meter cube is equals to 1 kg per meter cube is equals to 10 to the power minus 3 gram per centimeter cube. If you have to convert this SI to CGS unit, and this is how we do that. Okay. Now this is about density. Now we'll talk about the effect of temperature on density. Whenever we rise the temperature, whenever there is hot days, what happens is, I hope we have learned about expansion of material or expansion of solids. Whenever we increase the temperature, whenever temperature rises, the solid, liquid, whatever is there, it will expand. The size will increase. So the density will decrease. Whenever the size increases, temperature rises, density decreases. So in your book, it's written that density of most of the substance decreases with the rise in temperature. Suppose you take an iron. When you heat the temperature of the iron, the size of the iron ball will increase. So the molecules are moving away from each other. Ultimately what happens? It is less dense than it was before. So the density is decreasing, whereas the temperature of that ball is increasing. So it is inversely proportional. When we increase the temperature, the density decreases. And most of the substance, when we cool the substance from higher temperature, when we cool the substance, when we keep in the refrigerator, when we cool the substance will, the size will decrease, density will increase, substance will decrease. But there is an exception. That is for water. Water is a unique liquid which has got a different thing. For example, you have liquid at 100 degrees Celsius. This is actually known as anomalous expansion of a liquid, which is there in the next chapter. But I'll just tell you because we need to have an idea of this expansion. Okay? Suppose there is water at 100 degrees Celsius. It's boiling hot. Now when we decrease the temperature of this water, when we decrease, the liquid will, the density will increase. That means the liquid is becoming more denser. It means it is squeezing, okay? It will contract, the liquid will contract. And when we decrease the temperature, it will contract up to 4 degrees Celsius. Up to it is 4 degrees Celsius, the liquid will keep on contracting. The density will keep on increasing. The liquid will keep on contracting. But at 4 degrees Celsius, unexpected thing will happen. That is, instead of contracting, it will start expanding. Okay, from 4 degrees to 0 degrees Celsius, water will expand. Instead of contracting, it will start expanding. But from 100 to 4, it will contract. This is only for liquid. This is only for liquid, that is water. In the case of water, when anything at high temperature gets cooler and cooler, it will contract. Water will also contract up to 4 degrees Celsius, and after 4 degrees Celsius, instead of contracting, it will start expanding. That is known as anomalous expansion of water. It only happens with water, not with any other liquid. So the density of water is maximum. The density of water is maximum. When it contracts, the density increases. The density at 100 degrees Celsius and 4 degrees Celsius will be different. As we cool the liquid, the density will keep on increasing up to 4 degrees Celsius. At this 4 degrees Celsius, the density becomes maximum. Okay, the density at 4 degrees Celsius is maximum, which is around 1000 kg per meter cube or 1 gram per centimeter cube. This is the maximum density of water at 4 degrees Celsius. Now, why are we studying about water only? Because we need to relate this density of water with any other substance to find the relative density. So the next topic is relative density. ratio of density of that substance to the density of water at 4 degrees Celsius. If you want to find the density of any substance, if you want to find the relative density, then it will be density of any substance which you are trying to find with the density of water, which is at 4 degrees Celsius, which is an ideal number and which is fixed, okay, at 4 degrees Celsius. So this is relative density. Relative density of a substance is also defined as the ratio of the mass of a substance to the mass of an unequal volume of water at 4 degrees Celsius. So, you don't have to go in detail for relative density, just remember this particular formula for relative density. It is density of material divided by density of water at 4 degrees Celsius. Now the unit. This is also density, this is also density. So the unit of this density and this density will get cancelled out, and this has got no unit. So relative density is a unitless substance or a quantity, and relative density is actually a ratio, and ratio doesn't have any unit. So this is about relative density, and the difference between density and relative density is given in a book. There is a table, two differences there. First one is density is the density of a substance is the mass per unit volume of the substance. Density is mass divided by volume. SI unit of density is kg per meter cube, whereas relative density of a substance is the ratio of the density of that substance to the density of the water, and it has got no unit. Okay, that is relative density. Now in the next class we will discuss about determination of relative density of a solid substance by Archimedes' principle. So if this is clear till over here, we will continue with the same topic and the end of this portion in the next class. Thank you for today this much, and happy Dashara. Thank you.